Hello everyone, I am Abhishek Seni here to present a PPT on RTD. This is my assignment 1 of CRE2. My roll number is 19112003. So let us start. We start by seeing what is an RTD. RTD is an abbreviation used for the term residence time distribution. So let us see what is an residence time. The time taken by molecules to pass through the reactor is called residence time of molecule in the reactor. So the time taken by molecules to pass through the reactor, we call the term as residence time. Let us see what is a residence time distribution. The molecule take different path, hence residence time is not same for all molecules. The distribution of this time for the system of the fluid having the vessel is called RTD or exit age distribution. So when there is a case when molecules take different path or does not ideally flow through the reactor and take different path, hence the time taken, the residence time for the molecules is different. Then the distribution, so then this distribution of time across across for the system is known as RTD or exit age distribution. So when we see the case of an ideal plug flow reactor, all the molecules of material leaving the reactor have been inside it for exactly the same amount of time. So when there is an ideal flow in the reactor or ideal PFR, all molecules passing through the reactor take exactly the same amount of time as the other molecule is taking. Similarly, this is the case when we see for ideal batch flow reactor. So, similarly in ideal batch reactor, all the molecules of material within the reactor have been inside it for same length of time or same amount of time. Similarly as of ideal PFR. So the ideal plug flow and the ideal batch reactor are the only two classes of reactor in which all the fluid elements in the reactor have the same residence time. So these are the only two classes of reactor, that is ideal PFR and ideal batch reactor, where the where each and every fluid element in the reactor have same residence time. RTD. The residence time distribution of the reactor is a characteristics of mixing that occurs in a chemical reactor. So RTD is a property of mixing, is because of a mixing that occurs in a chemical reactor. There is no actual mixing in plug flow reactor, and this emission is reflected in the RTD. The CSTR is thoroughly mixed and processes a far different kind of RTD than plug flow reactor. So when we see the case of an CSTR, uh, the CSTR is thoroughly mixed and processes. So it has a different RTD than PFR. E. The age distribution of fluid. We find it convenient to represent the RTD in such a way that area under the curve is unity. So when we see the area under the curve, that is the yeah, curve between E and time across 0 to infinity, we see the area under the curve is 1. So integral 0 to infinity E dt is 1. One restriction on the E curve, that the fluid only enters and only leaves the vessel at one time. This means that there should be no flow or diffusion or upflow eddies at the entrance or the vessel exit. We call this the closed vessel boundary condition. So in this closed vessel boundary condition, a molecule can enter the vessel only one time and exit at one time. It cannot come back or re-enter the this reactor. So there should be no upflow eddies at the entrance or the vessel exit. There should be no eddies formed during the entrance and exit. Then this condition is called closed vessel boundary condition. Now we see open vessel boundary condition. So unlike the closed vessel boundary condition, where elements of fluid can cross the vessel boundary more than one time, so it can cross the boundary or the entrance and exit more than one time, then we call this condition as open vessel boundary condition. The fraction of exit stream of age between t and t plus dt, that is when we take a small time, that is dt. So between time t and time t plus dt, the fraction of exit stream of age is e dt. Now let us see the RTD measurement. The RTD is determined experimentally by injecting an inert chemical molecule or atom called a tracer. So when RTD is measured, we are injecting an inert chemical, or it can be a molecule or atom, that is tracer. So it does not participate in the chemical reaction happening in the reactor. Uh, it is a non-reactive species that can be easily detectable. It should also be completely soluble in the mixture. This type of chemicals or injecting to determine the RTD, we named this as tracer. So the RTD is determined experimentally by injecting an inert chemical molecule or atom called a tracer into the reactor at some time t equal to 0, then measuring the tracer concentration C in the effluent stream as a function of time. So when when we are injecting tracer at the entrance in the feed stream, and at time t equal to 0, then we are measuring the tracer concentration C in the exit stream and taking it as a function of time. In addition to being a non-reactive species that is easily detectable, the tracer should have physical properties similar to those of reacting mixture and be completely soluble in mixture. So there should be some properties for tracer. One is it should be a non-reactive species. It should not react with or does not should not participate in the chemical reaction taking place in the reactor. It should also be a completely soluble in the mixture. It should not be insoluble, and it should be easily detectable, and the physical properties contained by or the physical properties of the treasure should match with the reacting mixture, or it should be similar to those of the reacting mixture. It should also does not it also should not absorb on the wall or other surfaces in the reactor. So the latter requirement are needed so that the tracer's behavior will honestly reflect that of the material flowing through the reactor. So it should not take more than time of the molecules. So it should not it does not absorb on the wall. Colored and radioactive material along with the inert gases are the most common type of tracers. So there are two types of material, colored and radioactive material along with the inert gases. These are the most common types. Then the pulse input experiment. Uh, this pulse input experiment and step input experiment are the two type of experiment in order to find RTD. So in a pulse input, an amount of tracer is suddenly injected in one shot into the feed stream, entering the reactor in as short a time as possible. So there is an impulse injection into the feed stream for an amount of tracer. The outlet concentration is then measured as a function of time. So now let us see for step input. Step input. The output concentration from a vessel is related to the input concentration by a convolution integral. Pulse input, step input constant, volumetric rate, cumulative distribution. So this is now we will see characteristics of the RTD. So sometimes ET is called the exit age distribution function. If we regard the age of an atom as the time it has resided in the reaction environment, age means a time that the molecule resides in the reactor or an reaction environment. Then the E as a function of T concerns the age distribution of the effluent stream. It is the most used for the distribution function connected with reactor analysis because it characterizes the length of time various atoms spend at reaction condition. Thank you everyone.